For number 4, this boldly states that it is a Hess's law problem. Calculate delta H reaction for the following reaction here, given the other ones. So based on some of the Hess's law work we did earlier today, so I'm trying to create this top reaction from the bottom ones. And to do that, let's see, I'm going to zone in on this first reactant, N2H4. And I see that in the first reaction, it has a 1 coefficient, which is identical to the reaction I've got. So I'm going to start by writing out this reaction exactly as it appears here. And if I write the reaction exactly as it appears, then its delta H is minus 622. No changes. Then I see oxygens in all of these, so I don't want to mess with that. I do see 2 peroxides here, H2O2. And there's only one place the peroxide appears in any of these reactions. I can see 2 things. One is it's on the wrong side, so I'm going to have to flip this reaction. And I'm going to have to put a minus sign for the delta H. And here, I'll put that in parentheses, flip. And I see that peroxide has a 2 here. So I'm going to have to do 2's everywhere. And I'm going to have to multiply it times 2. So in the end, it's minus 2 for the delta H. And I flip it and multiply it times 2. Let me go ahead and do that. I always try to line up my arrows. So now I flip it. I have 2 H2O2. And I have 2 H2s and 2 O2s. And let me multiply this out. Well, question?
No, just see the answer, 374.
Oh, thank you. 374. Thank you very much. And now I got to do something with this third reaction. I've actually got, oh, hold on.
Professor, where do you get the 374 from?
It's actually 2 times 187.
Oh, okay.
Yeah. So actually, I don't know if you saw this. I just found this out. So this reaction only has a 2. I accidentally looked at the one up there, but this reaction that I'm trying to copy here only has a 2, so please correct that. Because otherwise it doesn't work. And remember, these always work. It may not seem like it at first, but these always come together. So now I see that I've got 2 H2Os and I need 4 H2Os. So I need to multiply this reaction times 2 and then I'll figure out everything else. So fingers crossed everything will work. Oh. Did you see what I did? I totally screwed this up, didn't I? Is there a message saying I totally screwed this up? Yes. Thank you, Manal. So what I said was when I screw these things up, I always just start over again. So please excuse me. Scribble it out. So I was taking this first reaction and I mixed it up with the one above it, and that was totally wrong. So let me try this again. Start with this one, write it exactly as it appears, and Maybe I'll save myself this time if I cover it up. So N2H4 liquid plus O2 gas goes to N2 gas plus 2, aha, there we go. Liquid delta H equals minus 622 kilojoules per mole. Sorry about that. Hopefully that makes more sense. Okay, now that I've successfully transferred that reaction, I can uncover it. And again, so these, that's one of my things is I just wasn't paying attention and I copied the wrong thing. So I cover it up to make sure that I copied, like I could have also just, well, somehow just focused in on that. Now let me see if I still need to flip this one. I think so. Yeah, because I was zoning in just on this one for the second one. So it is still flip it and times it by 2. Oh, what a mess I made of that, huh? But we recover. Now I got one reaction left. Does everything look okay so far? Now I know that I have 2 H2Os. I need 4 H2Os, so hopefully I can multiply this one times 2. And multiply this times 2. And I'm just going to do it and see what happens. So I get 2 H2Os for my products. I have 2 times a half, which is 1 oxygen. And 2 hydrogen.
2 yeah.
Thank you. And my delta H, I don't know what that is. 286 times,
negative 286
times 2. So negative 572.
572, yes.
Thank you. Lovely. Good teamwork. And now we add up the reactions and we add up the delta H values. And I see 2 oxygens. And those on the reactant side, so those cancel 2 oxygens on the product side. Then I see 2 hydrogens. And I see 2 hydrogens. And I think that's it. I do have 4 waters, but they're all on the product side. And I think we've just created our top reaction.
Yeah.
Antonio, I'll answer. Let me write this and then I'll answer your question.
4H02.
And then I add all these up. So I have 2 of them are negative, so
Negative 820.
Negative 820.
you did get negative 820? Good.
Yes.
Because I think that's what the answer sheet says. So I got this one right. And Antonio, to answer your question, why did I flip the equation for this one? And the reason I flipped it was in this reaction, there are 2 H2O2s on the product side. And my 2 H2O2s are on the reactant side here. And so when you flip it, that's going to put my H2O2s over on my reactant side. And then when we flip it, we have to do minus delta H, because you're basically making the energy of those reactants and products opposite. And opposite to energy means opposite sign. Great. Yeah, good question. Any other questions about this one?
Yes, Professor. I don't understand the cancellation of 202.
Okay, yeah, let me go over that. So now for a minute, we're just going to focus in on this part. And so I have one oxygen O2 here. I have another oxygen here. That's a total of 2. And I just so happen to have 2 together here. Like, it doesn't matter where they are. You can still cancel 2 with 2 in separate places.
Oh, okay, got it. Thank you.
Sure. And so one way of looking at this is, so whatever potential energy or whatever energy are associated with these 2 oxygens, it is equal to the energy or potential energy of these 2. So you're really canceling their energies when you're doing this. That's why we're doing the adding of the energies over here. And that's another way of thinking of it too. Any other questions about this one? And you can see there's actually 2 things. So if you remember the homework, there's a Hess's law problem, and then there was another problem on the homework that just said if you do flip the reaction, how does delta H change? And you would say take the negative of it. Anyway, that's